Okay, let's start. Oh, my voice is quite amplified. Is that too loud? Oh. Anyways, I'll try not to scream at everybody. So welcome to the last class before a well-deserved break. I hope you, most of you got your grade. So yeah, the average was around 60. Not too high, but well, not too low either. So now you see the format. It's going to be the same for the other exams. Just the final is longer. Yeah, and I'm going to tell you more information when I know it about how, if you want, you can see your exam results and discuss them.
Question. For people who didn't get their grades, when can we expect to get them back?
Say that again?
For people who haven't got their grades yet, like myself, when can we expect to get them?
Oh, so yeah, the thing is, some people used pen instead of pencils. Some people didn't input their names properly. So yeah, many things didn't. So all of these problematic cases are being dealt with by the Center for Exams or something. So yeah, as soon as we get back, hear back from them, I will upload your grade. So don't worry.
Thank you.
All right. So let us start. So today it's no slides at all. Purely, it's me doing some doodling there because I don't like the slides. So here we go. We finished with this last time, the ISOCANs. So they represent what? Combinations of inputs, capital and labor, which allow a firm to produce a certain quantity. So here Q equals 10. So just to step back a bit and remember what we were doing. So this is long term. Why is this long term? Because as a firm, I'm choosing everything. I'm saying, okay, so what's going to be my optimal size of my plant? Well, I'm going to use this many machines, this many labor, this much labor. So if I'm in, say, a labor-intense country, I might be over here. If I'm in a highly automatized country, I'm over here. So I'm going to limit as much as possible the number of workers I'm using and have lots of machines instead. And then, but the question is, what is the motivation for our choice? Why would we decide to produce, say, here, for instance? Oops. Yeah, so why would I produce here or why would I produce there? Can somebody tell me what's going to ultimately determine my choice? There is one thing that's not included there, yes?
It depends on the existing conditions. Like in China, there's a lot of labor and there's not a lot of capital, so it makes sense to use that labor.
Yeah. Yes, so the word I appreciate in your answer is expensive. So that's the question. How much does it cost me to hire somebody, or how much does it cost me to use some more capital? So let's introduce the last piece of the puzzle, which is prices. So let's go ahead and do that. So we're going to have something that is called isocost curves. So you may remember from our adventures in the consumer land that consumers were facing a budget constraint. Well, we have a very similar situation for firms. So firms have a sort of budget constraint, which is not exactly a constraint since they are allowed to employ as much labor or capital as they like, but they still face the trade-off of having to spend some money on either of these things and wanting to get the most bang out of the buck that they are spending. So, and the way we're going to represent this is with isocost curves. which you would, so I guess, so they tend to use PK and PL for the price of labor and price of capital, but yeah, so you can, so yeah, just as a reminder. So PK equals, so I'm going to say it's R, and PL is wage. This is just because that's in most of your life you're going to see R and W, so it makes more sense to put that there. But just in case you see in the book what is PK, what is PL, that's the rate, the rental rate or the interest rate and the wage. So here we go. So how much am I going to be spending? Well, my total cost will be C, and it is going to be equal to how much I buy or I rent machines. So K multiplied by what? So by the rental rate R. So R times K plus how much labor I hire, so how much workers I hire. But of course, this is multiplied by W, the wage rate. Oh, sorry about that. Yeah, so many operations to be doing right now. Here you go. All right, so this is, and sometimes you see S there for spending. So it's either spending or cost. So since we're talking about ISO cost curves, so let's represent them this way. And so what we had labor on the x-axis and capital on the y-axis. So let's still do that. And of course, they're going to look exactly as they were for consumers. It's just that rather than buying stuff I like to consume for myself, I'm buying stuff I need to produce in my firm. And how is this going to look? Is it going to be curved this way or curved that way? Is it going to be curved this way or curved that way? Or maybe curved this way. Now at home, you can see the screen, so you can help us too if you have some input. Yes, thank you, Mike. So that was a trick question. So it's not curved at all. You see that it is perfectly linear. So the R doesn't change however much I hire or I use capital, and W doesn't change however much I hire labor. So yeah, it doesn't change. And the way to look at it, you could say is let's represent K as function of L. So you would get this. So, yeah. So you would have, well, let me put that below to make sure that it doesn't get too crowded. So let's have K on the left-hand side, and here I'm going to have C, and then this is going to be minus. And I can just divide by R. So I get C divided by R, and W divided by R times L. Can we have the legend on the right of what each variable is? Oh yeah, sure. Where C is cost. Thank you, I forgot to put that. R is rental rate or interest rate on capital. Let's say it's interest rate on capital. Oh, rental. I don't know. I'm undecisive. K is capital. W is wage, right? and L is labor used. Let's put this a bit smaller. All right. So here you can really see that it's a function between, so K is a negative function of L. And yeah, so it's going to look like this. For instance, what is the slope of this? So I advise you look here.
Negative W divided by R
Times L?
or no.
Yeah, it's just the coefficient in front of L, right? Because that's L is here. So slope is negative W divided by R. All right. So do I have other things to say about this? No, I'm mostly done. And now, yeah. So let's just say, just put this here. And now where is going to be my choice? Well, I'm going to put the two together. So this is how much is going to cost me for, yeah, so essentially what this means is if I have a certain cost to use either as to hire workers or to rent capital, then how much could I have of either of them? Well, I can spend all of it as labor, all of it as capital, or half and half, for instance. And what is my optimal decision? Then I have to include back my isocost curves. So imagine I have one. I'm going to put to you two of them. And that one. Let me try and do a better job there. Yeah, like this. Okay, so question for you. Am I going to, okay, right. Usually when we present it like this, the question we ask is the following. How much? Yeah. So this, I'm going to make my, yeah, I'm going to get rid of this one. So this, the way to do it would be to have another one there. And another one there. Okay, so this one will be A. This one will be B. And this one will be C. Okay, so question. So, and imagine this is Q equals 100. Okay, that's my production. And the question is, how much do I need to spend to at minimum to produce Q equals 100? Yeah, so and here I'm going to have three isocost curves. So is the answer going to lie on curve A, on B, or on C?
Mike gave the answer.
What?
Mike gave the answer in the chat.
Oh, yes. So this is going to, and the tangency is at for curve B there. So good answer. So ISO cost. Curve B will be the answer. Yeah, I didn't write any numbers. Maybe I should have written some numbers that would have been better. Yeah. Okay, so imagine I made some effort in my graph. So this is okay. Yeah, I didn't think of this, but now that I didn't do it, I think it's not a good idea. So let's put numbers there. Okay, so those two are parallel. So imagine that I have, say, 10 workers, 5, or let's see, no, let's see, that's 30. This would be 15. This is 20 units of capital. And then this is what? This is 10. All right. And imagine that W is 1, R is 1, for instance. Then I have an answer. Then I know the total, the minimum spending. Oh yeah, and I don't even have an answer because I didn't give you what the number was here. So imagine it's here. Okay, so now I have an answer. Because in the appendix, they don't put too much detail in it, but I think it's good to have a real example. So here it is. So that's going to be 15. That's going to be 10. Yeah, it should be more or less straight. Okay. So answer, then I know that the minimum cost for producing Q equals 100 is C equals, so that's this, R times, so that's 1 times, here I have 10 units of capital plus 1 times, and I have 15 units of labor. So that's 25. All right. So this is how I find it. And so as was rightly said, it's at the point of tangency between the isocost curve and the isocons. Why do I know that? So, oh yeah, so let's get rid of this one there. So why do I know that this point here, so this point is so why do I know that this point is inefficient? You can give me 2 arguments that are essentially the same. Mike, are you there? Help us, please. It's related to your answer. Yes. Yeah, of course, I see that I'm employing more labor, but how do I know that as a firm that's a bad idea? Yeah, but I'm employing less capital than here. So yes, I know I'm employing more people, but actually I'm using fewer machines. So maybe it's better, or maybe it's not better. So what's the criterion for saying it's not as good? What's my goal? I just stated here.
Well, if you look just quickly, the labor is around 30. So right away, 30 is higher than 25, which is the combination of labor and capital. So automatically, and then we don't even know how much the capital costs. It looks like it's around 5, so it's probably like 35. So it's higher than 25. So it's definitely not right.
Oh, that's perfectly seen. So here is the argument. So yeah, that's a killer argument. I have nothing to say against that. So here's what I had in mind. Is exactly the same argument as for consumers. So you look at here, and what we see here is yeah, rental right and capital exceeds the wage right. No, both are one. So that's not the point there. So the point is, yeah, higher cost is the point. So if you start from here, so I can ask myself, what are the alternatives to choosing this specific set of inputs? Well, let's travel on a isocant curve. On an isocant curve means I still produce Q equals 100. So that's my goal. My goal is to produce 100, whatever I choose. And then if I travel around this way, what do I see is that I hit this curve here, which is represent a lower amount of ISO cost. So if I had said, for instance, this is like 31 or something, and this is like 7, then you could have known what is the cost of what this ISO cost curve is. But anyhow, you know it's on the right of that one. So ISO cost curve increase this way. This is expensive. This is cheap. So that's a way of seeing, yes, if I can move in this direction and still produce the same quantity, so I'm going to hit a lower ISO cost curve until I get here. Another way of saying the same thing is the following. So rather than following the isocant, let's follow the iso cost. So this is saying I'm still going to spend as much as I'm spending here. And lo and behold, I'm probably able to hit a production point that is higher than I would here. So I can, for the same cost, be producing more units. So again, this has to be better for me in some ways. So that's why anytime these are intersecting but not tangent, then you know you're at an inefficient point. So anytime in macroeconomics you see some choice between two inputs or two consumption goods, have a budget line. So just look for where there's a tangency point. That's where things are, good things are happening. That's the optimum. And what do we deduce from this? Well, we know that the slope is minus W over R. What was the slope of the, so yeah, optimum.
Is that arrow still pointing at the?
Oh, it's just this, oh yeah, no, it is not, thank you. So the slope, and by the way, that's the same slope for every curve. It's minus W over R. So optimum is when the isocost curve is tangent to the isocant. I don't know if I should say it's yeah, I should say isocast line because it's not a curve, it's a line because it's a straight line actually. So yeah, to the isocant curve. And if you remember, so the slope of the isocant was, so since they are tangent, then what we have to know is that the slope of the isocant or isocast must equal the slope of the isocant. And very briefly, I'm going to show you again what was the slope of the isocant minus marginal productivity of labor divided by the marginal productivity of capital. So then we deduce that. So minus W over R has to be equal to minus marginal productivity of labor divided by the marginal product of capital. And this is, and then what did we find? What did we see earlier in the chapter? We saw that, so at the optimum, and just remove the minuses there. So W over R has to be equal to this, or another way of saying the same thing is marginal product of capital divided by, my marginal product of labor divided by W has to be equal to the marginal product of capital divided by the rental rate. These are all saying the same thing. And what this is saying is at the optimum, it must be the case that if I am to get more labor and less capital, then I should get as much bang for my buck as it costs me to, I should get as much bang as my buck costs me. So that's where the expression comes from. So the economists have invented this expression. No, I'm kidding. Right. So let me just ask you a more tricky question. So this is, advanced question, but let's go for it. So imagine I'm here and here. And here, let's have some like other one, but let's try it again. Let's use another. Q, let's say Q equals 50 here. It's getting a bit crowded, but it's manageable. And this will be 7.5. And this would be 5. So if you want to know, this is half, this is half. And then my question is, from this point to that point, what is the return to scale? So do I have decreasing returns to scale, constant returns to scale, or increasing returns to scale? So that's going back to, again, previous class, but we can all see it here. So it's a bit more difficult question, but you can think about it. So do I have, let's just see between little a and little b. So between question. Between.
you have the terms from start.
Yeah, which are so increasing, decreasing, or constant.
It's increasing.
Yeah, constant, right? Why?
Because it's the same productivity, it's just a copy of.
Exactly. So what did I do here? I had exactly half the labor employed, half the capital used, and I was able to produce a quantity of 50. Then I double my labor input, I double my capital input, and I hit this new isocant where I produce 100. So I exactly double my inputs, exactly double my cost of production, and I exactly double my quantity. So yeah, constant return. So answer. So, but you know, I wouldn't expect all of you to see this. It takes time to understand all these things. It takes coffee too. We doubled all inputs and double the cost. And exactly double the quantity produced. Okay, do I still have some space here? Yes. Okay, so last question. So imagine that relative price between labor and capital changes. So for instance, imagine this goes here and this goes here. So yeah, let's have this be this one there. So here more expensive, or yeah, it could be less expensive too, more expensive. So labor. So why do I know it's labor that's more expensive? Well, so that the slope is steeper, and I know that the slope is minus W or R. So the steeper it is, so the bigger W is, and the smaller R is. So so I don't know what happened in the labor or the capital market. All I know is now the relative cost of either inputs are different. And then what would I choose? I would probably choose point C there. All right. I would just hold the firm would substitute labor to capital, so or would so it's not clear, would use less labor and more capital. And produce at point C. So that's, yes, I don't know, we might call it the substitution effect, substitution principle or something. So essentially what I'm doing is I'm shifting. So if the cost of hiring labor rather than using more capital increases, so what do I do? Well, I decide, oh, so that thing is too, so at B, it would be too expensive, because you see that the same for ISO cost at the new relative cost, then I would probably be somewhere like here, for instance. So rather than that, I'm going to, and it wouldn't be tangent anymore. So then I'm going to choose C, which is the new tangent point, where here I have shifted away from labor towards more capital. So this is more capital intensive. This is more labor intensive. So maybe that would have happened if the country had become more industrialized, for instance. So by the way, last week I went to Decathlon, and I was shocked. I couldn't find anybody at any cashier. And so I said, where do I pay? And over there, but I didn't, there's nothing. And there's just a few boxes. So, but as soon as you get close, then the box sort of detects, oh yeah, he's buying shoes or a shirt or whatever. And then that's how much it costs. So yeah, nobody is taking your money there. Compare that to before, where you would have had many people to take your money. So yeah, slowly but surely, we're shifting towards a world where there are fewer and fewer workers. And yeah, this has to do with the fact that you are too few people. So, so back in the days, we would have many students working as cashier at Decathlon, but nowadays, nobody wants to work there. So that's the story of industrialization. I didn't write anything there. Okay, so I thought I'd written something. So more expensive labor. Oh yeah. So okay, sorry. All right. So what time is it now? 9:22. So we have until 10, right? So I think that's mostly what I wanted to say about this. Did I forget something? No. Okay, so question about all of this? Yes, sure. Here I should say, to be more precise, I should say relative to capital. This is all in relative terms. Because if both R and W increase by the same amount, then all these isocost curves are going to shift up. So, but so what matters is their relative cost. Okay, so that would be the end of this chapter. We will move to. Yeah, sure. Okay, so okay. So next chapter would be chapter 9 or 8? 9? 9. Okay, so chapter 9. So I'm going to go back. Don't worry, I'm going to go back to the slides in chapter 9. It's just that I don't feel like they tell stuff, but they don't show stuff. So this thing is show, don't tell. So if I show you where things come from, then everything makes sense. And then if you see it written down, then okay, yeah, that's what it is. So competitive firms. I don't remember the title, but it's somehow this competitive firms. So here is, and we're going to see it in the short term. Okay. So we're going to be asking questions asked in this chapter. One thing I have to say that we're going to see again in the slides is that what's special about competitive firms or firms in competitive markets in perfect competition is that they are minuscule compared to the amount of stuff that's being bought and sold everywhere. So they know for a fact that they cannot affect the market price. They have to take it as a given. And this is good for us because it makes our lives much easier in terms of analysis. Although not as interesting. So I think the chapters on imperfect competition, monopoly, oligopoly is much fun. But that's me talking. That's the economist talking. So, but yeah. So for now, it makes things very easy because all we have to ask ourselves is the following: if the market price today is, say, $10, how is this firm going to go about and do its business? So we have looked at cost curve all over the place, but I've told you what really matters is the difference between costs and benefits. It's how much I make as a firm when I produce and how much I have to pay to produce it. And so this is what's going to dictate my, my decision. And again, I'm going to just look out there and see that everybody's trading at $10 today. So I have to take the best decision I can, given the fact that the price today is $10. And so the question that we're going to see is the following. So given a certain market price, so one, will the firm produce or not? So it might or it might not. If the price is too low, then it's better to not do anything. Two, and by the way, we're not going to start by one. We're going to start with two. That's easier, and then deduce what one is. So if the firm does produce how much?
People online can't see the slides, by the way.
What is that?
Oh, we can't see the slides on Zoom.
Oh, yeah. Sorry, my bad. Yeah. Yeah, when I'm at home, I think of switching, but then I forget. Okay, so yeah, that's what I have written there. So I'm asking these questions. How much will it produce? Oops. Then three, what's the firm supply? So that's a result of 1 and 2. So as when we do answer 1 and 2, then we can say what the firm supply is, because the firm supply is how much it produces as a response to what the price is. So that's what the firm supply is. We have seen this at the market level, but that's what every firm does. So I see the price and I decide what's my production. And finally, 4, does the firm make a profit? Or does it make positive profit? And then 5, so something that we see later is if firms make profit, then they are joined by other firms. because there's money to be made. And if not, yeah, let's be sophisticated and use all the punctuations we can use. They will exceed the market. Yes, some will. But this is so long term. So here, short terms are, so I should say, not that, but long term. Okay, all right. Yeah, so yeah, be careful what you're doing, because saying, because everybody can hear you. But yeah, that's the same in Zoom anyways. Okay, so here, here's how we are going to answer all of these questions. So what does the firm care about? Somebody remembers?
Profit.
Yeah, profit. Look around you, everything is explained by money. Yeah. So the firm cares about profit, which we write capital, oh no, capital by, yeah. So what is the firm's profit? It's pi equals to P times what? I use the capital Q, can be a small q too. Let's use this, where P is sales price and Q is quantity, and C is cost. So I didn't write it this way, but you could write C of Q, because it's obviously a function. So the more I produce, the more it's going to cost. Sorry, the more it's going to cost me. But yeah, I want to keep things as clean as possible, but know that, of course, this is not a function. This is something that I see out there. It's $10. It's $10. I cannot choose it. What can I choose? I can choose Q, but of course, if I produce more, then I'm going to have more costs. So yeah. So just bear this in mind. So what is my optimal production Q? What's my optimal production?
One that maximizes profit.
Yes, that which maximizes profits. So if by increasing Q, I make more profit, I will increase Q. And of course, if by decreasing Q, or I should say, if by increasing Q, I make less profits, I will produce less. So what's going on there? Well, this is a classic optimization problem. I am disallowed to go too deeply into the math. It doesn't matter. But so you just keep this in mind. If I produce zero, then probably I'm going to have zero revenue, and I might still have costs to pay, which are fixed costs. So the cost of, so if I decide today, let's not open up my firm, anyways, I have still the electricity bill, many sorts of bills I have to pay, even if I produce zero. So I'm going to have a negative profit. So the only way to start having a positive profit is at some point having a good enough price so that I think it's useful to produce. And then I'm going to make a good profit. But as we've seen, so if in the short run I produce too much, then what happens? Well, at some point my costs become too big because, for instance, if it's a restaurant and even if people were willing to pay me much higher to dine in my restaurant, well, at some point it's still going to cost me even more because I'm just limited by how much I can serve them. So C is going to increase too much. So there is some optimal Q at which the profit is maximized. So just in a nutshell, to maximize Q, what we do is to maximize profit, we produce, or the firm produces such that. So when they increase, oops, yeah, let's take this. So when the so what is the increase in profit if I increase my quantity? So then if I increase my quantity minus my increase in price, then this is going to be equal to 0. And usually you say that, yeah, okay. So you see that if I increase Q and make more profit, I produce more. If I increase Q and I make less profit, I produce less. So what's the optimal? It's when I increase Q such that I also increase C, but what is the yeah, so optimal decision. Yeah. Increase Q and it changes, it doesn't change my profit. So that's delta Q equals 0, delta profit equals 0. And we usually express it as delta profit divided by delta Q. So another way of putting this is delta profit divided by delta Q. This I get delta Q divided by delta Q, so that's 0. And delta C divided by delta Q equals 0. Somebody remembers what is delta C divided by delta Q? How much the cost increases as a result of the increasing quantity? The last decision, but yeah, awesome. So where delta C divided by delta Q is the marginal cost. So it's the marginal cost of producing an extra unit gives me what? Gives me just enough that it's paid back by how much I'm going to get on the market selling this unit, which is the price. So this, and the price, what is? The price is the marginal revenue. So the optimal decision is that the marginal revenue equals the marginal cost, or the price equals marginal cost. All right, so now to represent this. Yeah, awesome, I have enough space. So this, I just did it mathematically in some ways, but now you can really see what's going on if I have a small graph. So so the marginal cost is the really important thing there. So imagine I have some price. So what color I'm going to use? Blue for my price. Yeah, I should maybe write down what this is. So this is price, and this is quantity. Okay, so it's not. So in the previous graph, what we had was labor on one side and capital on one side. So it was some resource on one side, resource on the other. Here, we're back towards something that's more like a market, where we have quantity on the horizontal axis and price on the vertical axis. And we have, so first thing to note is that the market price is constant. So whatever my quantity as a firm, whenever I choose to produce, then the market price is constant. I'm small, I don't matter. I just do my own stuff on my street corner, but it's not going to change anything about the market price on the street. All right, so whatever my quantity is. As a whole, of course, if the market produces much more or much less, then consumers will decide to produce, to pay less or to pay more. But now this is what it is. And then let us draw our cost curves. So yeah, let's have a marginal cost curve in red. So we can draw it like this, for instance. This would be the marginal cost. And so what do I have here? I have price, marginal cost, and what did I say? The optimal decision. Oh, I didn't even write it. Oh, I'm sad now. Okay, so what I'm going to do is make this a bit smaller. Yeah, it's just I wanted to have a neat expression, because that's like the important thing. So oh, say that again. Oh, why the change in profit has to be equal to 0? Okay, because so the change in profit as a function, as a reaction to the change in quantity, right? So I'm a firm, I decided to produce 100 units today. And then I'm asking myself, so was that a good decision or not? Well, what happens if I produce 102? Oh, my profit is actually higher. So yeah, I should still increase my production. And then, oh, if I increase again to 100 bigger production, oh, my profit increases again. Okay, I keep going. But then you see, so let's just look at what's happening on the graph there. Each unit, extra unit that I decide to produce will always give me what, when I sell it, its sales price. So if it's $10, then each unit I choose additionally to produce is $10. But maybe here I'm really good here. Here I'm at cruise control. So each unit costs me very little and I make a big chunk of money. The chunk of money I make for each unit is the difference between the price and the marginal cost. But then here I'm starting to run out of room, of capital, of resources. So if I still want to try and produce more, well, what do I see? It starts costing more. And here, if I still want to really produce, well, tough luck. Here it's going to cost me much more to produce the last unit than I can sell it on the market. So this is exactly why we want that the increase in profit divided by the increase in quantity be 0. So that's where the marginal cost equals the price. Yeah, so the only thing I wanted to, so yeah, no, awesome question. That's the core of the matter. So it's so then crucial result. So price equals marginal cost defines the optimal production decision. So let me, so yeah, that's so let me put a yellow box around it because that's important. Price equals marginal cost. So this answers the question number 2 there. If the firm does produce, how much will it produce? It will produce such that the price equals marginal cost. And this will happen exactly at this production there. Exactly there. So I could say this is Q star. Right. Then the question is, will the firm produce or not? Okay, so how should I do that? Yeah, it's a neat graph, so let's continue on. So at this point, Q star, what is my profit? Yeah, I have this. Okay, so first question. So will the firm produce or not? And again, we're going to start by using equations, but then it's going to make a lot of sense with the rest. I see that I was too ambitious in the space I used. Yeah, what should I do? What should I do? Yeah, the thing is, what I don't like is, yeah, okay, I'll build it again. See, it's I cannot like select all at once. That's the thing I don't like with this this program. But all right, let me take a few seconds to transfer there. Q, P, and P, and marginal cost, and marginal cost. All right. Okay, so I'm back down. All right, so yeah, and let me share this new screen with everybody. Okay, so now the first question was, will the firm decide to produce or not? So we started by asking if the firm does produce, then what is going to be the production? We see it's Q star defined by price equals marginal cost. So to answer that, let's go back to what the profit is. So if the firm produces, the profit is pi equals to P times Q star. yeah, that's not too good. So yeah, PQ, so you have to know that's the optimal quantity, Q star. Yeah, let's write it this way. Okay, you know, this is a multiplication and this is just minus the cost. But let's be a bit more specific. So where cost is the total cost. Yeah, so I could have written TC there, but yeah. Which was, so do you remember what the total cost is? It's equal to, yeah, let's just write it this way. It's equal to two types of costs.
The fixed cost and
Yes, fixed cost,
the variable cost.
variable cost. Okay. Okay. Yeah, let me write it this way, where the total cost is the fixed cost plus the variable cost. C equals FC plus VC. So let us substitute this. So I'm going to have minus fixed cost minus variable cost, okay? Because this is minus cost, so this is minus fixed cost minus variable cost. So this is what I pay if I do produce. And then if the firm does not produce, so if the firm does not produce, then what's the profit? Equals P times, oops. What's Q?
0.
Yeah, 0. But as we said, the fixed cost, we still have to pay it. And then what is the variable cost? 0. So then the question is, again, what do? I do what's best for me, what gives me the higher profit or the less bad profit. So the decision, so firm produces, if this is bigger than this is just equal to minus fixed cost. Yeah. That makes sense. Yeah, okay. And let me even a bit more specific. So variable cost, I can multiply it and divide it by Q here. So note. Variable cost, yeah, average variable cost is equal to the variable cost divided by Q. You do remember this, right? So then what I can do is say that variable cost is the average variable cost multiplied by Q. So this is equal to the, yeah, let's write it here. average variable cost times Q star. And I can put the Q star in front. So I had that the price minus the average variable cost times Q star. Oh yeah, so this is oh yeah, I could have gotten rid of the fixed cost too. I didn't think about it, so as to be greater than 0. Yeah. So that's simpler. And you see that whatever Q is, then it has to be the case. So whatever Q is, here I have 0. So I can just divide by Q essentially. Yeah, so I get that P has to be greater than average variable cost. Okay, yeah. Sorry, that was a bit messy, but we got there. So I'm just going to go back to the steps that I used. So here I said what the firm gets if it produces. Well, it gets price times quantity minus fixed cost minus variable cost. If the firm does not produce, then it doesn't get any variable cost to pay, but doesn't get any income either. So the only thing it gets is minus fixed cost. And the decision to produce or not is whether or not the profit by producing is higher than the profit by not producing. Which we get, which is this one here. So I just, and here I just substituted average variable cost times Q instead of variable cost. And I find essentially that this is the case. So the firm is going to produce whenever the price is larger than the average variable cost. So it means, so essentially what this means here is that on average, I make more money on the units I sell than it costs me to produce them on average. So let me just draw it very quickly. So where is my average variable cost? So it could be, let's draw it in purple, for instance. So it's something like this. Now, if you don't know exactly what the shape of the average variable cost is, so don't worry. It's the only thing that matters is again that the marginal cost will cross the average variable cost at its minimum. And here, of course, the firm is going to produce because the market price is higher than the average variable cost. All right, so that was a bit intense to finish with this. So don't worry, we're not done with this chapter. So we're continuing here next time. So I hope you have a nice break. And as for people who didn't get their grade, as soon as possible, I'm going to input them. All right, thank you.